L'Hopital's rule is a very powerful tool for computing limits when we run into indeterminate forms. However, it cannot always be used. In this video, I want to present an example of a limit for which L'Hopital's rule is not legal. We may not use it, but we may easily not notice that and use it anyway, and then get a wrong answer. This is the example. I invite you to pause the video and try to compute this limit, and in particular think about what will happen if we use L'Hopital's rule to compute this limit. After that, continue watching. I want to compute the limit as x approaches infinity of x plus sine x over 2x plus cos x. This is a quotient, so first I'm going to look at the limit of the numerator and denominator separately and see what they are and see if I have an indeterminate form. We know the limit of x is infinity and sine of x oscillates between -1 and 1. So what I can say is that x plus sine of x is always greater or equal than x minus 1. And so sine of x is pretty much irrelevant here, because what's happening is that the limit of x minus 1 is certainly infinity. So if x plus sine x is greater or equal than a function that goes to infinity, then x plus sine x also goes to infinity. In other words, sine x is pretty much irrelevant, and the limit of the numerator is going to be infinity. To a certain extent, this is like the version of Squeeze theorem for infinite limits. If the function is greater than something going to infinity, then it goes to infinity. That's for the numerator. For the denominator, the exact same thing happens. Cosine of x is as irrelevant as sine of x. So I do have an indeterminate form of type infinity over infinity. That's the situation in which I can apply L'Hopital's rule normally, right? So let's do that. Let's use L'Hopital's rule and see what happens. Okay. If I'm going to use L'Hopital's rule, I say that the limit of this quotient is going to be equal to the limit as x approaches infinity. And in the numerator, I put the derivative of the numerator. The derivative of x is 1. The derivative of sine x is cos x. And in the denominator, I put the derivative of 2x plus cos x, which is 2 minus sine x. And now, what's the limit of this new function? Well, I'm not sure, but notice that the function is periodic. It's a periodic function with period 2 pi. So if I look at the whole quotient, I don't know exactly what it is like, but it's periodic with period 2 pi. So for example, if the graph of the function, which I say is continuous, is something like, I'm making this up, like this, then it will continue repeating periodically. And so on. So the function is not going to have a limit as x approaches infinity. A periodic function will never have a limit as x approaches infinity unless it's constant. But periodic and non-constant means this doesn't have a limit. So this limit does not exist. Does this mean that the original limit doesn't exist? Well, not so fast. As a reminder, this is what L'Hopital's theorems say. In order to apply this theorem, I need to satisfy 4 conditions, and the fourth one in particular we often forget about, but it's important. In order to use L'Hopital's rule, I need the second limit, the limit of f prime over g prime, to either exist or be infinity or minus infinity. If it doesn't exist for a different reason, then I cannot apply L'Hopital's rule. The theorem doesn't apply, it doesn't give me any information. So back to our example. In this case, the limit of f prime over g prime does not exist, is not infinity, and is not minus infinity. So L'Hopital's rule doesn't help. I cannot do this, and I still have no idea what the original limit is. I'm back where I started. I don't know what this limit is. So what can we do? Well, let's try to calculate it directly without using L'Hopital's rule at all. I said before that to a certain extent, sine and cosine are irrelevant, because as x approaches infinity, x is much bigger than sine, and x is much bigger than cosine. Can we make that formal? Yes, we can. What I can do is divide numerator and denominator by x. This is a common strategy, just divide by the largest term. So, if I divide the top and the bottom by x, I get the following. And now, what can I do with sine x over x? Well, if you've encountered a term like this before, this is asking us for a squeeze theorem. Because sine of x is always bounded between -1 and 1, and x is approaching infinity. So sine of x over x is always bounded between 1 over x and -1 over x. And now, as x approaches infinity, 1 over x is, well, has limit 0. And minus 1 over x also has limit 0. So sine x over x is sandwiched between two functions with limit 0, and therefore by squeeze theorem also has limit 0. So in our calculation, this term has limit 0, and this term works exactly the same way and also has limit 0. So as x approaches infinity, the quotient ends up having limit 1/2. And that is the answer. That's it, without using L'Hopital's rule at all. So coming back to the original question, the limit of f over g is equal to 1/2. So to summarize, the limit I was trying to compute is 1 over 2. It is definitely an indeterminate form of type infinity over infinity, but if I try to use L'Hopital's rule, the limit of f prime over g prime doesn't exist, is not infinity and is not minus infinity, therefore L'Hopital's rule is forbidden, and in fact would give the wrong result, since the limit does exist and is equal to 1/2. To be fair, this is a very particular situation. If you use L'Hopital's rule regularly, this is a situation that you will not encounter often, but it is important to know that it can happen.